Hi everybody. Sorry I can't be there in person. What happened was I had coffee with a friend and everything was great. And then the next day she texted and said, guess what? I tested positive for COVID today. So neither of us knew she was sick. And then I got sick toward the end of the week. And so I had to get tested for COVID. And here I am at home. I can't be there with you in person. Anyway, we are going to go through by video the lessons that you'll be going through this week. So thank you to Mrs. Pinnell for being with the class, and here we go. You'll be working on lessons 73 through 76, so we're working on decimals. So remember the first part of the word deci, it refers to tens, and so we're talking about portions of 10. And of course, it's not, we've talked about this, right? It's not just tenths. So we have our decimal, and let's say we had a decimal like this, 36241.36241. So this first place would be the tenths, so a portion of 10, tenths. And then another multiple of 10, 100ths is next. And then 1,000ths. And then 10,000ths, 100,000ths, and so on, because in numbers, in the number world, we can go forever. Numbers are infinite. Isn't that incredible? Okay, so these are portions of 10 or factors of them. Notice it's, ooh, I just colored on my carpet with a marker. Oops. Notice these are ones with a 0. So, decimals. Okay, so let's talk about adding decimals to, or subtracting them to a whole number. So what if we say something like 6 plus 14.75? What do we do? Well, you have done this kind of thing before. It's not all that tricky, but let me show you what you could do. You can think 14.75, we have a decimal that goes 2 digits back. So we're here in the hundredths spot, right? Guess what? 6, it has nothing past the decimal. Would it be true to say that 6 is the same as 6.06 and 0 tenths? Is that true? Yeah, that just means 6 and no parts of 10. Yeah. We understand that about just plain 6. We just don't write it. Is it also true that 6 is the same as 6 and 0 100ths? Yeah, we understand that about plain old 6. It's 6 and nothing else. We just don't write it. There's no need to write that there's nothing more than regular old 6. So when you are going to add these two numbers, one thing you could do is instead of writing plain 6, write 6.00 and go ahead and add. So it looks like this, 14.75 plus 6.00. Remember what we said? Line up the decimals. If you don't do that, you'll get the wrong answer. You'll be putting things in the wrong place value. So here we go. And then it's business as usual. You know how to add something like this. 5 and 0 is 5. 7 and 0 is 7. We follow where our decimal point is and put it right there underneath exactly where the decimal was here. 4 plus 6 is 10, so we put the 0, carry our 1. 1 plus 1 is 2, 20.75. What if you think to yourself, why do I have to put 0, 0? It doesn't add any value or change any value about 6. Well, you're right. Here's something you could do. You could write plain 6, but you have to be very careful. If you had 14.75 and put 6 there, it would be wrong. Why? Because your decimal on 6, even though we don't write it, is actually right there. If you did that to add it together, your decimals would not be lined up. Not okay. So if you're just going to put plain 6, put it in the right spot. 6 is in the which place value? The tens, not tenths, tens. So put it right there. But you're still going to have to think to yourself, okay, I've got empty space. You've dealt with empty space before with addition. You simply treat your empty space like 0. So you can do it much like we did it when we wrote it as 6.00. 5 plus 0 is 5. 7 plus 0 is 7. Now, you'll still have to put your decimal where it belongs, right there. 4 plus 6 is 10, just like before. Carry the 1, and we get the same answer. So if you want to write it that way, that's fine, as long as you put your decimal in the right spot. Okay, what about subtraction? What if we said, 8 minus 3.45? Well, that's a little bit funnier. We said you could, back in the previous addition problem, we said you could write 6 with no decimal points after. After all, 6 is the same thing as 6.0. 6 is the same as 6.00. 6 is the same as 6.0 as many times as you want to say it. That's true about 8 too. 8 is the same as 8.0, and the same as 8.00, and the same as 8 point any amount of zeros. But if you write it like this, 8 minus 3.45, notice how I lined them up? Decimal point after the 8. You're kind of left with a little bit of a pickle. How do you subtract 5 from thin air? How do you subtract 4 from thin air? This is a time with subtraction where I suggest you don't neglect putting your zeros. Is it true that 8 is the same as 8 and 0 100ths? Yeah, it is. We just don't usually write the 0.00 because we don't need to always be saying that 8 means 8 and 0 left over. But here it's helpful so we can see what we're going to subtract. Well, you line up your problem, decimals on top of each other, ones on top of each other, tenths on top of each other, hundredths on top of each other. And once you've done that, business as usual. 0 minus 5, can't do it. Let's borrow. That becomes 9, that becomes 10. 10 minus 5, 5. 9 minus 4, 5. Put your decimal below the other decimals. 8 minus 3 is 5. 5.55. What if you're going the other way around? 2.98 minus 1. Can we do that? Sure we can. 2.98 minus, where will I put the 1? Oh, it's understood that the decimal comes right after it. We better put the 1 in the 1's place. Here it's a little bit simpler if you don't end up putting the decimal and the zeros after it, because you know how to subtract empty space from a number. We've done that in previous problems. 8 minus 0 is simple. 9 minus 0 is simple. Decimal underneath 2 minus 1 is 1. Now, if you had your zeros there, is it going to change anything? No, and it just might help you keep your things in line a little better. 1.00, let's take a look. Is it true that 1 is the same as 1 and 0 100ths? Yes. So we write it that way. Helps us keep things in line. Decimals lined up, just like before. 8 minus 0 is 8. 9 minus 0, 9. Decimal goes underneath the decimals. 2 minus 1 is 1. There you go. Subtracting with decimals. Whole numbers and decimals, that is. Alrighty, let's look at your next chapter. This is where you're going to, now we've multiplied decimals by decimals. What about decimals multiplied by a whole number? Can we do that? Yeah. What about this? 1.13 times 6. Wait a second, Mrs. Ord. Your decimal is here after that whole number 6, and on top, your decimal's there. Is that a problem? Yes, if we were adding or subtracting, but in multiplication, it doesn't matter. You take care of those decimals later, remember? Well, let's go ahead and multiply. There's no need to put zeros after the 6 since in multiplication, we don't have to line up the decimal numbers. In multiplying by zeros, will just give us zeros anyway. No point putting those there. All right, let's multiply. 6 times 3, you know how to do that. 18, carry your 1. 6 times 1 is 6 plus 1 is 7. 6 times 1 is 6. And remember what we did? We counted in our multiplication problem how many digits were to the right of the decimal. Let's go ahead and count. Ooh, none past 6. 1, 2 on this other number, 1.13, 2 places. So we'll take our decimal. Instead of starting at the very back of the number, we'll go 1, 2 places over to match what we had there. Your answer, 6.78. Okay, what if it's the other way around? What if it's 60 times 0.3? How do we do it? No problem. Same thing as we just did. It's just your decimal is going to be in a different spot. 3 times 0 is 0. 3 times 6 is 18. In our multiplication problem, how many digits to the right of the decimal? 1 there on 0.3. There's my point. I don't know if you can see it. And 0 on 60. So we take our decimal from the very end and move it 1 in, 18.0. When you give your final answer to teaching textbooks or anybody, let's say somebody just asked you, hey, tell me the answer, 60 times 0.3. Would you say 18.0? Probably not. You don't need to say the 0.0. It's understood when we say 18. That's your more finished answer, to say 18. Okay, let's look at some other stuff here. So do you have to line up the decimal points when multiplying a decimal and a whole number? No. When subtracting and adding a decimal and a whole number, do you have to line up the decimal points? Yes. Okay. By the way, if someone were to ask you, does a whole number have any decimal points to the right of the decimal? Probably the technical answer is no, but you sure could write them. You always could put zeros at the end of a whole number after the decimal. Let's talk about multiplying decimals by 10, by 100, by 1,000, by 1 followed by any number of zeros. You could do it really easily. Okay, let's say your number is this, 32.91. Ew, who wants to multiply that 4-digit number by anything? It's not so bad when you're multiplying it by 1. Whoops, well, that's easy. How about by 10? It's kind of like multiplying it by 1 or 100 or 1,000. Let's try it. Let's multiply by 10. Well, we have a shortcut we have talked about before when you multiply any number followed by zeros. Let's skip the shortcut for now and just do it longhand so you can see it really turns out like we say. All right, 0 times 1, 0. 0 times 9, 0. 0 times 2, 0. 0 times 3, 0. Ooh, that's nice. Okay, next one, we put a 0 there because now we're in the 10 spot. We have to account for that. We're going to start one place over. 1 times 1, 1. 1 times 9, 9. 1 times 2, 2. 1 times 3, 3. Ooh, wasn't that easy? Let's add our 2 rows. Well, that's not hard because we're adding all zeros to this. So let's write it down, 32910. Let's account for our decimals. We have 1, 2 past the decimal in our multiplication problem. 1, 2. Here's our answer, 329.10. A more finished way of saying this would be 329.1 because we don't put things that we don't need to put in our number, generally speaking. We don't need to add that there are 0 100ths. It's enough to say there's 1/10, and we all know that every other place after that's going to be 0 if we leave it that way. 329.1. Oh, that looks an awful lot like what we started with. What's the only difference? Aha, the decimal is 1 point to the left. Instead of being 0.91, now it's just 0.1. Does that work for bigger numbers? Let's try it by multiplying times 100. If that pattern continued, let's save this over here. 329.1 is when we multiply 32.91 by 10. If this pattern continues, I wonder if multiplying it by 100 would make 3,291 with our decimal there. If you multiply by 10, 100, 1,000, 10,000, and so on, do you just move the decimal? Let's try it with 100. All right, we're going to do it longhand. Okay, 0 times that. 0, 0, 0, 0. Start with a 0 here. Now we're also multiplying by 0. Everything's 0. We have 4 numbers. We're multiplying by 0 there. A lot of zeros. Now we write 2 zeros because we're on our 3rd digit already. 2 zeros to account for that. 1 times 1 is 1. 1 times 9 is 9. 1 times 2, 2. 1 times 3, 3. Let's add everything. All zeros. All zeros. 0 plus 0 plus 1 is 1. 0 plus 0 plus 9, 9. 0 plus 2, 2. 3 plus nothing, 3. How many digits to the right of our decimal up here in our multiplication problem? 1, 2. Oh, 1, 2. Our answer, 3,291.0, which is the same as 3,291. It worked as I predicted. Guys, a shortcut. Anytime you multiply any number by 10, 100, 1,000, 10,000, 100,000, and so on for infinity, 1 with however many zeros after it, you multiply any number by that, you're going to move your decimal to the right as many decimal places as you have zeros in the multiplier. So let's try it. Say we have 1.18 times 1,000. How many zeros do we have in this multiplier? 1, 2, 3. The answer will be 1.18. Only move our decimal 1, 2, 3 because we had 3 zeros. 1, 2, 3 places over. But there's nothing there. What do we put if there's nothing there in our place? 0. The answer would be 1,180. How about this one? 192.2 times 10,000. 192.2 times 10,000. We would be moving our decimal 1, 2, 3, 4 places to the right, and that's the only thing that's changing. Let's go ahead and do it. Let's write down all those digits, 1922, and we're going to move 1, so there, 1, 2, 3, 4 places over. That means we need 3 zeros. Our new number would be 1,922,000. That's how you do it. Easy peasy. You just move the decimals as many times to the right as the number has zeros that you're multiplying by. Not a hard thing. All right, now let's talk about dividing decimals by whole numbers. So we added decimals to whole numbers, subtracted decimals from whole numbers, or the other way around, subtracted whole numbers from decimals. On both of those kinds of problems, addition and subtraction, anytime you're dealing with a decimal, line them up. Then we multiplied. We multiplied whole numbers and decimals. Do we line up the decimal there? Nope, don't have to worry about it. And we learned a shortcut when you're multiplying by powers of 10, so that would mean 1 followed by any number of zeros. Let's talk about dividing decimals by whole numbers. So let's say you have something like this. 342.9 divided by 3. How do you do it? Guess what? The same as normal, only you put your decimal there. Keep that there in your answer. That'll be important. All right, 3 goes into 3. How many times? 1. 1 times 3 is 3. Subtract, you get 0. Bring down your 4, right? This is so familiar. You've divided like this for a long time. 4. How many times can 3 go into 4? Once. 1 times 3 is 3. We get 1 left over. Bring down our 2. 3 can go into 12. How many times? 4. 4 times 3 is 12. We get 0 left over. Bring down our 9. Ooh, there's a decimal there. Is that going to change what number we write down? Not at all. We're still going to see how many times can 3 go into 9. It's just we have a decimal there. 3 can go into 9 3 times. And you know 3 times 3 is 9, so we'd have 0 left over. There's our answer. Don't forget that decimal, 114.3. It needs to be right there or your answer will be wrong. It's very important. Okay, that's it. Let's review a couple things. Let's review dividing fractions. Okay, so there was dividing decimals. Let's review dividing fractions. What is 1/2 divided by 1/4? How do you do that? Remember, we take the second number, invert, and multiply. Let's rewrite this. So we don't change the first number when we divide fractions, do we? 1/2. Let's invert. That means 4 over 1. And multiply. We know how to do a problem like this. We can do a few things. We could plain old multiply numerators by numerators, denominators by denominators, and expect we might have to reduce. Or one trick to help us eliminate some of our reducing, we can cross cancel. Let's look and see if we can cross cancel. Do 1 and 1 share any factors besides 1 in itself? No, it's already 1. It's as low as it can go. How about 4 and 2? Do they share factors? They're both divisible by 2. We can divide 4 by 2 and get 2. We can divide 2 by 2 and get 1. Now it's going to be really simple. All right, multiply tops by tops. 1 times 2 equals 2. 1 times 1 equals 1. There's our answer. Is that as finished as it needs to get? No. It's whenever you have a fraction with 1 as a denominator, remember what that equals? It equals just the plain numerator as a whole number. That would be your finished answer. Let's do one more division review problem. I want to go ahead and divide one more decimal by a whole number just to practice, make sure this sticks in your brain. So what if we have 19.44 divided by 4? Do we have to do anything at the beginning of this to take care of the decimal? Yes. We put the decimal right up here where our answer is going to go to remind ourselves in the answer, this decimal has to remain consistent with the place that it was here under the division sign, right? Then do we do anything different? Business as usual. You know what to do. Can 4 go into 9 any times? Nope. Let's move over 1. Can 4 go into 19 any times? Yeah. 5 would be too big because 4 times 5 is 20. 4. 4 times 4 is 16. That's what we put. 4. Put 16. Subtract. We get 3. You know what to do. Bring down. Wait a second, but there's a decimal. That's okay. It's not going to change anything we're doing about the division. So we bring down the 4. 4 can go into 34 how many times? Well, 4 times 8 is 32. 4 times 9 is 36. So 9's too big. 8's a little bit too small, but that's the right one. That's okay. We could be a little bit too small, but we can't be too big. So 8. 8's our next part of our answer. 8 times 4 is 32. Subtract, we get 2 left over. Bring down the 4. Ooh, it is very funny to write upside down, let me tell you. 4 can go into 24 how many times? 6. 6 times 4, 24. So nice and even. 0 left over. What's our answer? 4.86. The only thing when you're dividing a digit, or when you're dividing a decimal number by a whole number, the only special thing to keep track of is put the decimal on top where your answer will go. And that way you're sure that your answer is going to be in the right form. Okay. Let me just make sure that's all I want to tell you. Let's practice a story problem together. This is actually one that is going to be in your lesson 76. So if you have a pencil and you want to write this down and save yourself some trouble, it might help you not only remember how to do it, but it might help save you a little bit of effort later. So this is the word problem on lesson 76. Let's do it together. The shipper told Monique, who's the shipper? Well, you know, like when you order something on Amazon and they tell you your shipping cost, or maybe you order something from, I don't know. My daughter ordered a bunch of t-shirts for Christmas presents. There was a t-shirt company and you have to pay a certain amount of shipping. Maybe FedEx is your shipper, or UPS or USPS, right? That's your shipper. All right, the shipper told Monique, the wedding planner, that 9 heart-shaped tables she wanted weighed a total of 21.4 pounds. Wow, she's ordering a lot of heart-shaped tables. So if she's gonna order those, she'd have to pay for a lot of weight. If you have ever ordered something to be shipped, you know shipping goes up the bigger your package is, right? So 221.4 pounds, that's gonna be pretty heavy. She's gonna look at a lot of shipping. Okay, if each table weighed the same amount, how many pounds did each table weigh? We had 221.4 pounds and 9 tables. How much is each of the table weighing? That means if we were to divide this whole thing by 9, we would find out how many pounds each one was. Can we divide 221.4 by 9? Well, you know how. All right, divide it by 9. What's the special thing when you're dividing a decimal number by a whole